We're going to look at fractional distance. What this means is that we want to go part of the way from one point to another. How we're going to be doing this is we're going to be using basically the slope, the change in y and the change in x, and going a partial slope step the direction it wants us to. That's how we're going to locate our landing point for the answer. So we have the endpoints of segment LM given to us, L at -4, 1. I'm going to go ahead and plot that. So -4 and 1 on the graph here. So that is point L. Point M is at 5, -5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Be very sure that you are plotting these correctly. If I mess this part up, nothing else will be right. So there we go. That is segment LM. We are going to be looking for points along this segment that are a certain distance from one end or the other, depending on what they tell us. It says, what are the coordinates of the point that's 2/3 the distance from L to M? So we're going to start at L. I'm going to go ahead and highlight L because that's going to be our starting point. So I'm going to do some color coding so we can, this is a two-part question. So I'm going to want to start at L for this one. And like I said before, we're going to be basing this off of slope. And slope is a change in x and a change in y. Usually slope we think rise over run, so we can look at the vertical change first or the horizontal. It doesn't really matter. But we're going to be going part of the way vertically, part of the way horizontally. How we're going to start was we're going to look at the vertical change and the horizontal change and just say how far apart they are. So let's look at this vertical change. 1, 2, 3, 4, 5, 6. It's 6 movements vertically. Let's look at the horizontal change. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 across. So we have the vertical distance and the horizontal distance of the total segment. Now we wish to go 2/3 of that distance. So if we want to figure out 2/3 of the distance, we need to think about 2/3 of 6. Well, 2/3 of 6, 2 times 6 is 12, divided by 3 is 4. So the vertical change that we wish to do is a change of 4. So the segment's going down, so we're going to go down 4. So that is our new vertical distance that we would like to go. Now for the horizontal distance. It's currently 9. We want to go 2/3 of 9. Well, 2/3 of 9, 2 times 9, 18, divided by 3 is going to give you 6. We wish to go a horizontal distance of 6. We're going from L to M. That is the distance going to the right, because that's the direction that that segment is going. That M is to the right of L. So we're going to go 6 to the right, and I'm going to go ahead and put that at the bottom of this orange arrow where we decided our vertical change was going to be. And so we can see down 4 there on that orange arrow, and over 6 on the green arrow there is going to put us at a landing spot right here. And they want to know the coordinates of this point. So it is at the point 2 and -3. So that is where we are landing for 2/3 from L to M. Now it says, what about 2/3 from M to L? Well, we already have the numbers that are 2/3 that represent 2/3, but we want to go the other direction. So we want to go from M to L. So rather than going down and to the right, we're going to go up and to the left. So we're going to go up 4, because that was that 2/3 change there. So 1, 2, 3, 4. This is the vertical distance, and we want to go left 6. So 1, 2, 3, 4, 5, 6 puts me right here on the line segment. And so I am now at the point -1, -1. So that is that second part of the question. And so it's all related to slope, going the partial distance, that partial slope amount in the correct direction based on what letter they're telling you to start from. So it takes practice. Please do practice these questions. They're not bad, But you need to get the process down so that, in a testing situation, you're comfortable with it, and you look at the question, you see that fraction, and you're like, oh, I know what to do here. And then you just go with that process.